Hello students. So today discussion is about, in this chapter, language of chemistry, how to name the compound. So in the previous videos we completed the discussion about how to write a chemical formula, yes or no. So not just writing the formula students, even naming is also equally important. So in this video we'll cover how to name certain types of molecules, covalent molecular compounds, ionic compounds, acids, bases, everything we'll cover in this video. So first of all, to start, while there are many thousands of different chemical compounds, there is a very different system of nomenclature where we can name or write the chemical formula for most of the compounds. Yes, there are millions of compounds, yes, sir, students. For all these compounds, definitely we should follow a systematic procedure or not. So we have a certain rules to name the compounds. Let us start the discussion first. Naming of binary compounds. Naming of binary compound. Binary means two. Yes, sir, students. That means the compounds which are made up of two elements are called as binary compounds. Simple. So in general, so you can see naming of binary compounds. What type of binary compounds? Ionic compounds. Ionic compounds means what they are made up of, students. We already practiced how to write a formula between a metallic cation as well as non-metallic anion. Yes or no? An ionic compound is made up of a metal as well as non-metal. Now, how to write the name? Clear. The metal name is directly coming from its element name. Yes or no? The metallic part in the compound is directly coming from the element name only. For example, so NaCl, what we are writing for Na? Sodium. Are we writing any separate name for that ion which is present in that compound? No. Half of the point is clear. Yes or no? For the compounds involving metals and non-metals, metal part name is directly coming from its elements name, right? Clear? Then what about the non-metallic part? Non-metallic part, students, only one small change you have to do, that is the last part of the non-metallic name should end with IDE. IDE should end with IDE. For example, NaCl is not sodium chlorine. NaCl is sodium chlor. You have to take only chlor and you have to replace that with the remaining part with ide. Sodium chloride. The name of the compound is sodium chloride. So this is the only step, only rule you have to follow. Metallic part directly from element name only. From non-metal, they should end with IDE. A cation is always named first and then the second is anion. This is first. Are we saying chloride sodium? Are we saying chlorine sodium? No. What we are saying? Sodium chloride. What is the formula? NaCl. Are we writing ClNa? No. According to IUPAC, a metallic cation should be represented first, followed by a non-metallic anion. Why? That's a rule given by IUPAC which gives certain guidelines for naming the compounds. But there are reasons, students. There are reasons also. The reason is cation formation means what? Losing electrons, yes or no? Anionic formation means what? Gaining electrons, yes or no? Which formation takes place first? Cationic formation or anionic formation? Obviously, for an atom to gain electrons, some atoms should lose electrons, yes or no, students? So that's why cationic formation takes place first, followed by the anionic formation. So that's why a cation is represented first, followed by an anion, or electropositive element represented first, followed by electronegative element. In the naming also you have to follow the same. First metallic first name, followed by the non-metallic part. Sodium chloride, it's not chloride sodium. Got the clarity? That's the first one. A simple cation obtained from a single atom takes its name from the name of the element. Single cation means positive. Can non-metals be positive? No, metals only. So their name is directly coming from the element name. A simple anion obtained from a single atom is named by taking the first part of the element name, that is the root word, as well as adding the letter IDE by ending with ide. For example, chlorine becomes chloride, oxygen becomes oxide, sulfur becomes sulfide, nitrogen becomes nitride, yes or no? Bromine becomes bromide. So non-metallic names should end with IDE. That is the only thing you have to remember while writing the formulas. Examples, we have two examples are given here. Let us try to name the compounds. Already the formulas given. What is the formula? CaO. So here you already know calcium is a metal, oxygen is a non-metal. So what is the name of this compound, students? First, Ca means what? Calcium. Yes, sir. Is there any change in the name of that particular cation? No, directly from its element name, calcium only. Is it calcium oxygen? No. Here we have oxygen element. Oxygen is a non-metallic anion. So what should it end with? It ends with ide oxide. So the name of the compound is calcium oxide, CaO. Got the clarity? Binary compounds, ionic compounds, metal name should be represented first, followed by the non-metal name, but non-metal name should end with ide. That's it. That is what naming of these binary compounds. That's the only rule. Next, naming of the compound Li3N. So you try to name this compound, students. Li3N. What is the meaning? What is Li? Which element? Lithium. Is there any change in this name? Nothing. There is no change in this name, lithium. And N represents nitrogen. So can we directly write nitrogen? No. Is it lithium nitrogen? No. So but nitrogen should end with ide. That INE replaced by IDE. Right? So lithium nitride, NITRIDE, nitrogen, that gen is replaced by ide. Lithium nitride is like if you any n number of compounds you can name. MgCl2. You answer, students, what is the name? MgCl2, magnesium chloride, or Ag2S, silver sulfide, KCl, potassium chloride, NaBr, what is the name? Sodium bromine. Is it sodium bromine? Sodium bromide. Got the clarity? So binary compounds means two elements are there. One is a metal, non-metal comes under ionic compounds. So metallic name first represented first, followed by non-metallic name. Next, type 2 binary compounds. Type 2 binary compounds means these are also ionic compounds, but the metals are with variable valencies. Variable valency concept also we discussed in the previous video. Sir, no, some metals can show more than one valency, and how to name these type of metals also we completed the discussion in the previous video in part 2. So here I will just repeat the points once again. For example, iron. Iron has two valencies. What are the valencies of iron? Fe+2 and Fe+3. Yes or no? If there are two different valencies, the lower valency should end with OUS and the higher valency should end with IC. That means Fe+2 is called as ferrous, Fe+3 is called as ferric. Let us consider one more example. Sn+2, Sn+4. So what are the names? Stannous, stannic. Yes or no? Not only according to the OUS and IC forms, we have one more type, students. One more type, that is called as according to the Roman numerals also. Yes or no? What is that Roman numeral? What does it indicate? It indicates the valency of that element. Look at here. So this type 2 binary compounds, what do they indicate? For which type of compounds all these rules represented? For the compounds where the metals show variable valency. So the cation is always named first, followed by anion. This is simple, that is common. Simple cation obtained from the single atom takes its name from the name of the element. Include a Roman numeral to indicate the valency on the metal cation. How to find that I will explain. A simple anion is named by taking the first part of the element, ends with ide. Write the names of the compounds. Okay. So all the rules are same, everything same, but only one change. What is that change? For the metallic part, you have to represent a Roman numeral. What this Roman numeral indicates? The charge, the valency of the metal. Sir, why do we need to represent? Why? Because that metal can show one more valency. Yes or no? For example, FeCl2 is there, FeCl3 is there. You are simply naming iron chloride. Which iron chloride are you talking about? FeCl2 or FeCl3? We should give the difference or not? That's why. So FeCl2, what is the valency of iron? How to find? Iron combines with two chlorines. In valency concept in the previous video we discussed about finding valencies. Sir, students, iron combines, chlorine valency is 1, iron is combining with two chlorines. That means what is this iron valency? 2. FeCl3, iron is combining with 3 chlorines. Then what is the valency of the other iron? 3. So how to name this compound? Iron 2 chloride. This one is iron 3 chloride. That's it. So look at here. Look at this name. Already the same example is given here. FeCl2. What is the chlorine valency? Students, chlorine valency is 1, right? Here iron combines with how many chlorines? 2 chlorines, right? So what is iron valency? Iron valency is 2. So the name of the compound is iron 2 in brackets, and the remaining part is same, chloride. That's it. PbS2. PbS2. Students, what is the valency of sulfur? Sulfide, S minus 2, no, 2 sulfurs are there. That means each sulfur 2 Two sulfurs are there. Total how much is the valency on the sulfur side? 4 is the valency. And all the 4 valency is balanced by how many lead? PB, plumbum, how many lead atoms? Only one lead atom. That means lead has valency 4. So what is the name of this compound? LEAD, lead 4 sulfide. That's it. These are the names. Can I give few more examples? You just try. Second. AuCl, AuCl3. These are the two compounds. In both these compounds, metal is gold and the non-metallic part is chlorine. Chlorine should end with chloride, that is common. But here, simply can we say gold chloride? If you are saying gold chloride, which gold chloride are you talking about? Is it AuCl or AuCl3? We can say sodium chloride simply. Why? Because is there any other formula? Does sodium show variable valency? No, there is no problem in that case. In the case of first type of binary compounds. Here, what is the case? These metals can show variable valencies. That's why we have to indicate the Roman numeral. So gold, how many? Is it combining with how many chlorines? Only one. So what is the name? Gold 1 chloride. Here gold is combining with, aurum is combining with 3 chlorines. So what is the name? Gold 3 chloride. That's it. Got the clarity, students? So this is how to name the second type of binary compound. So next, type 3 binary compounds. Type the binary only. Binary means 2 elements only, students. Binary. But type 3 means there is some difference. It's a huge difference, not a simple difference, that I will tell you. Type 1, type 2 binary compounds are called as ionic compounds. That means they are made up of ions. Simply, you already know cation and anion. But type 3 binary compounds are not ionic compounds. They are called as molecular compounds. So what is the difference? What is the difference? From the beginning I am saying in this chapter, chemical reactions takes place by 3 ways. What are the 3 ways? By losing electrons, by gaining electrons, by sharing electrons. Yes or no? So ionic compounds are produced by losing and gaining. These 2 ways, right? What about the third one, sharing? That is molecular compound. Okay, how do they share? We have the discussion, the chemical bonding, not enough. But just remember, when a compound produced by sharing the electrons, that compound is called as molecular compound. If the compound is produced by either by losing or gaining, both should happen, na? That compound is called as ionic compound. So how to identify? How to identify the compound? Whether it is an ionic compound or molecular compound? Simple. Simple. Students, ionic compounds are always made up of a metal and a non-metal. Always metal and why? Because what is the nature of metals? Metals always show tendency to lose electrons. What is the nature of non-metals? Non-metals always show tendency to gain electrons. So metals always form cations, non-metals always form anions, and the attraction between cation and anion is called as ionic bonding. Got the clarity? So one is clear. Second, how to identify the molecular compounds? Molecular compounds means this sharing, majority times this sharing of electrons takes place between non-metals and non-metals only. Of course, there are some exceptions with lithium, beryllium and magnesium, aluminium. Exceptions are there. We are right now we are not going into that exceptions, but general statement is a molecular compound is definitely being found between both non-metals. Ionic compounds, one is a metal, one is a non-metal. Molecular compounds, both are non-metals. I'll give you examples to identify whether the compound is ionic or molecular. So, one second, students. Sodium chloride, is it ionic or molecular? Sodium is a metal, right? Chlorine is a non-metal, right? This is ionic compound. H2O, is it ionic or molecular? Hydrogen is a non-metal. Oxygen is a non-metal. So the compound is molecular, like that. Carbon dioxide, what is the formula? CO2. What are the non-metals? What are the elements present? One is carbon, second one is oxygen. Both are non-metals. So what is the compound expected? Is it ionic or molecular? This is molecular compound. So type 3 binary compounds is about molecular compounds. So how to name these compounds, that we'll discuss in this video. So first element in the formula is named first, and then full element name is used. First the element in the formula is named first and the full element name is used. So whatever the element which is represented in the first, it should be named first. For example, here hydrogen represented, here carbon is represented. Here also why only carbon represented, why not oxygen? The same reason, electropositive element represented first, followed by the electronegative, more electronegative. Less electronegative is also there, na students, between non-metals also. The same procedure. Second element is named as an anion, root ide. This point also same. Second element should always ends with ide, the highly electronegative element. Prefixes are used to indicate the numbers of the atoms present. This is the main point. Prefixes are used. This is the difference between naming of type 1, type 2 with the type 3. What we have to use? You have to use prefixes. If the second element, for the second element, if there is only one element, what is the prefix? Mono. 2 element, di. 3 elements, tri. 4, tetra, penta, hexa, hepta, octa, nona, deca. These prefixes are used. Sir, why do we need to use these prefixes? We are not using these prefixes in the case of the previous compounds. For example, look at here, AuCl3. Are we saying this is gold trichloride? No, we are not doing that. Then why we are doing here? You know, students, the reason is the same non-metal combinations can form more than one compound. For example, we have a formula of SO2 as well as SO3 also. We have a formula of CO2 as well as between same elements we have one more formula called as CO also. We have a formula H2O as well as we have also the formula H2O2 hydrogen peroxide. Yes or no? So in that case definitely we have to mention the repetitions only. So these repetitions are used. So for example, nitrogen is the chemical symbol of nitrogen. Since there is only one, look at here, name the compound NO2. First you name. What is the compound, students? The first element, directly write the name. What is the first element? Nitrogen, right? So write nitrogen. There is no change. What is the second element? Should end with ide. That is common. What is that? Oxide. That's it. No. What is the primary? What is the principal difference between type 1, type 2 and type 3? Prefixes. How many oxygens are there? 2. So you have to mention dioxide. Nitrogen dioxide is NO2. That is the difference. And this is molecular compound. Nitrogen is a non-metal. Oxygen is a non-metal. Got the clarity, students? So oxygen is the chemical symbol of oxygen, where O is where root is ox and ending ide. There two oxygen atoms, so we have to add the prefix di to get dioxide. Now write the formula of carbon tetrachloride. Now the name is given, you have to write the formula. What is the name? Carbon tetrachloride. Carbon means what's the symbol? Clear? Next, tetrachloride. Tetra means how much? 4. You don't write 4. You already know how to write the formula. Tetrachloride means how many chlorines are there? 4 chlorines are there. So CCl4. That's it. Carbon tetrachloride. Got the clarity, students? So we have other examples also. I'll give you the other examples. For example, students, SO. For example, not SO, SO2, SO3. What are the names? This is sulfur dioxide. This is sulfur trioxide. Next, COCO2. What are the names? Carbon monoxide. This is carbon dioxide. SF4, SF6. What are the names? Sulfur tetrafluoride, sulfur hexafluoride, like that. So for these molecular compounds, for these type 3 binary compounds, you have to mention the repetition, the prefixes for the second element which is represented in the formula. Why second, why first also, you already know the clarity. Electropositive element first represented, next followed by the electronegative element. So that is all about these molecular compound, students. Next, naming of the ternary compounds. Ternary means 3. If a compound is made up of 3 elements, mostly it contains oxygen. So most of these compounds, students, should end with 8 or 8. That's it. But there are some exceptions like cyanide. This is Cn minus. Cyanide ends with ide. Hydroxide also ends with ide. Peroxide also ends with ide. Superoxide. There are some certain exceptions, but in general, ternary compounds, majority of them are either 8 or 8. That means if 8 or 8 is present, what is the common element in that particular compound present? Oxygen. You have to remember that. So let's see some of the examples. Look at here, Na2SO4, students. What's the name? You have to remember the formula, which is SO4. That is sulfate, sodium sulfate. And look at here, when do we get the ite? If the formula having 1 oxygen less than 8, then it ends with ite. So what is sulfate is SO4, right? Now you say the formula sulfite, SO3, that's it. Or whatever the metal present here, directly the metal name, there is no change. Here are we writing sulfide? No, don't write sulfide. Why? Because this is not binary compound, this is combined with oxygen, so you have to write 8 or 8. Sir, how to write 8 or 8? You have to remember one formula. Based on that, you have to remember 8 formula. From 8 formula, you can write 8. That's it. Simple. Okay, sir, how to are you asking how to remember also? No, right? So Na2SO4, sodium sulfate. If it is MgSO4, magnesium sulfate, that's it. CaSO4, calcium sulfate. Metal name is not changing. Okay, only that combination with oxygen, that name changing to 8, not ide and ite. Na3PO4, what is the name? Is it sodium phosphide? No, it's not single phosphorus, there is oxygen. So sodium phosphate. If it is PO3, phosphite. This is copper to nitrite. Yes, sir, So with this nitrite, can you imagine nitrate formula? Nitrite is 1 oxygen less than 8. Yes, sir, every time. Now you imagine nitrate. If it is NO2 is nitrate, what is nitrate? NO3. One more oxygen. Yes, sir, no. That's what. Next, potassium dihydrogen phosphate, KH2PO4, dihydrogen phosphate. FeNO3 taken thrice, the variable valency. Iron 3 nitrate, calcium hydroxide, and cobalt 2 perchlorate. The name of this radical is called as perchlorate. Chlorine contains more. For example, ClO3, this is chlorate. ClO2, you say the name? Chlorite. Now ClO, hypochlorite, here ClO4. ClO4, that means if one oxygen more than 8, that is called as perchlorate. So perchlorate. NH4 taken by Cr2O7, ammonium ion. This radical also we discussed in the previous examples. Ammonium, and this radical is called as dichromate. So ultimately, the names of these compounds are coming from their radical names only. There are few very simple rules are there where you have to remember, like ite, that's it. Next, naming of acids. What are acids? What is the definition of an acid? The substances which can release H plus ions are called as an acid. Yes, sir, students. So, for the common acids, you have to start with hydro binary acids. Acids contains only 2 elements. For these acids, you have to start with hydro, ends with ic acid. In between, you have to write that element, whatever the element acid it is made up of. So HCl, what say? Hydrochloric acid. That's it. HF, hydrofluoric acid. H2S, hydrosulfuric acid. Yes, sir. HI, hydroiodic acid. So that's what for binary acids. What if in case of ternary acids? Ternary acids means what? One more element. Mostly what is that element? Oxygen. In that case, don't use hydro, only ic acid. The element name ends with ic acid. For example, look at this acid H2SO4. What is the element present? What is the main element? Hydrogen is common. For oxy acids, oxygen is common. The other non-metal is changing, sulfur. So what is the name? Sulfuric acid. H3PO4, what is the other element? Phosphorus, phosphoric acid. H2CO3, carbon, carbonic acid. HNO3, nitrogen, nitric acid. That's it. So for oxy acids, these are called as oxy acids. Why? Because they have common oxygen. Of course, hydrogen is common for acids, all acids. So for these acids, no need to mention hydro also. For binary acids, we have to mention hydro, ends with ic. For normal oxy acids, directly ic acids with the respective non-metal present. Got the clarity, students, about acids? Now we have bases, naming of bases. What's defined base? What's a base? A base is a substance which has a capacity to release OH minus ions according to Arrhenius. Yes, sir, in aqueous medium. So OH minus, they have the characteristic OH minus ions in their formula. What's the name of OH minus? Hydroxide. If this OH minus, if it reacts with, if it combines with metal, that is called as an acid, yes, sir, obviously. So you already know how to write the metal name directly from the element, ends with hydroxide. NaOH, what's the name? Sodium hydroxide. NH4OH, ammonium hydroxide. CaOH taken twice, calcium hydroxide. KOH, potassium hydroxide. MgOH taken twice, magnesium hydroxide. There is no confusion also, simple. For bases, directly hydroxides. Starts with a metal or a radical, whatever that name, ends with hydroxide. Next, trivial names. Trivial names mean, students, we all know this. All these compounds, like, are they found recently? No, some compounds are being used from very olden days, from very ancient times. So those compounds, not necessarily we mention their chemical name. We call that compound by its chemical name. we call that compound by its common name. That means general name. Generally that is being called by that name from long days. So we are calling that. For example, the best example is H2O. What is the name of H2O? Everyone knows that. Water. Is it a chemical name? No. Water is not a chemical name. That's a common name. That name is being in use from very ancient times. So that's why. But what is its chemical name? H2O. Its chemical name is hydrogen hydroxide or hydrogen monoxide according to the chemical. Yes or no? So that, but are we calling it with the chemical name? So these are trivial names or common names. Some compounds which are old compounds, old, all are old only, but they're used, they're been called from olden times. That's why they have common names. We used to call them with their common names instead of chemical name, but still they have chemical names. Look at here. Nitrogen trihydride. Only hydride is given. It is nitrogen trihydride. It is commonly called as, what is the name, students? Ammonia. What is the formula? NH3. So NH3, not every time, like in the chemical reaction, wherever we are representing. So we are following all these rules now, students. So while writing NH3, what is the first thing which comes in your mind? Sir, it is nitrogen trihydride, and why you are calling it as ammonia? That's the reason why we have this slide. So some compounds we don't write, we don't pronounce, we don't say by their chemical names, we follow their common names. So this is ammonia. Next, salt. Are we calling every time it's called sodium chloride? For example, cooking. Where is sodium chloride? Are we saying like that? No, simply we are saying where is salt, where is stable salt, where is common salt? Yes or no? So what is the formula? NaCl is generally commonly called as stable salt or common salt. Next one is, students, water. What is the formula? H2O, hydrogen monoxide, hydrogen hydroxide, like that different chemical names are there. Next, potassium nitrate, KNO3, commonly called as niter. So why this potassium nitrate is also been in use from the olden times? Why? Because it is used in gunpowder. It is also used as fertilizer. Even ammonia also used as a fertilizer. Magnesium carbonate, MgCO3. MgCO3 is also called as magnesite. Its ore, it is coming from its ore. So like this, few compounds, not all the chemical compounds have common names. What are the compounds which are in use from the olden days? Only have common names. Remaining all we have to pronounce, you have to say with their chemical name only. So that is what about the naming of ionic compounds, molecular compounds altogether comes under binary compounds, as well as naming of ternary compounds, which includes oxygen, naming of acids, bases, and common names. This chapter is completed, students. I hope you got the clarities. Thank you.